You've probably noticed that AI just seems to get what you mean, right? It's not magic, and it's definitely not just about matching keywords anymore. Today, we're going to pull back the curtain on the secret language of AI to see how these machines actually understand concepts. And really, it all comes down to a question like this. For us, it's totally obvious. King, queen, royalty, they belong together. But for a computer, which just sees ones and zeros, how does it possibly grasp that abstract connection? Well, the answer to this is pretty much the key to all of modern AI.
You've definitely experienced this massive shift yourself. We've gone from the old way of searching, where you type summer shoes and only get results with those exact words, to this new way where the AI understands the idea of summer shoes. It knows you mean things like sandals or breathable sneakers. It's a huge leap from just matching words to actually getting the meaning.
But to really appreciate how huge this leap is, we've got to look back at the early attempts. The first tries to teach computers our language were, pretty clever, but they hit a massive, massive wall.
This early approach was called one-hot encoding. And here's the gist of it. You take a huge dictionary, say 50,000 words. The word cat would then become this super long list of 50,000 numbers, and they'd all be zeros except for a single one marking the spot for cat. It's simple on the surface, but it turned out to be a really bad idea.
And here's exactly why it was a total dead end. First, those lists of numbers were gigantic and just wildly inefficient to work with. Second, they were sparse, which is a fancy way of saying they were full of useless zeros. But the real killer, the thing that stopped everything, was that there was no concept of meaning. To the computer, the distance between cat and dog was exactly the same as the distance between cat and car. Every single word was its own lonely island.
So, if that was a dead end, how did we solve it? Well, the solution was a true paradigm shift. It was this brilliant, almost simple idea that turned meaning into something a computer could finally work with. Geometry.
Instead of just making a long list of words, researchers had this breakthrough moment. What if we could map words? What if we could create a sort of multidimensional meaning space, where related ideas are actually placed close to each other? All of a sudden, these abstract relationships became physical distances a computer could measure.
Probably the best way to picture this is with the library analogy. Just imagine this giant digital library, this huge vector space. In this library, concepts are organized by topic. So king and queen are right next to each other on a shelf in the royalty section. Meanwhile, table is way over in the furniture aisle. A word's meaning is simply its address, its location on this giant map. And this is where it just gets wild. You can literally do math with these meanings. So if you take the map coordinate for king, and you subtract the coordinate for man, and then you add the coordinate for woman, you end up almost exactly at the map coordinate for queen. This is the proof. The AI isn't just memorizing definitions. It's actually learning the web of relationships between ideas.
But, okay, the story doesn't stop there. That amazing breakthrough was really just the starting line. This whole idea of meaning maps has been evolving at a crazy pace, and it's gotten so much more powerful. I mean, think about it. In just about a decade, we went from word to vec, which gave every word one single, fixed meaning, to models like BERT, which could finally understand that the word bank means something totally different in riverbank versus money bank. And then we got models like CLIP, which took the craziest leap of all, mapping the meaning of pictures and words into the exact same map. So that big leap was really all about solving the one word, one meaning problem. The early models, like word2vec, gave a word like bank a single permanent address on the map. But the newer models, the contextual ones like BERT, are way smarter. They look at the entire sentence around the word and create a unique meaning on the fly. They finally capture the nuance of how we actually talk.
Okay, I know this all sounds a little abstract and theoretical, right? But this technology, what we call embeddings, is the invisible engine running behind so many of the apps you use every single day.
So let's go back to that e-commerce example. When you type in a conceptual search like that, the system turns your whole phrase into a vector, a coordinate on the map. Then it zips through its database looking for products whose descriptions have the closest vectors. That's how it knows you're not just looking for the word cool, but for things like breathable sandals. It gets your intent. And once you start looking, you see it everywhere. This semantic understanding is what powers smart search. It's the secret sauce in your Netflix or Spotify recommendations, finding other movies or songs that just feel similar. It's what lets modern chatbots find really specific, nuanced answers buried in documents. It's even used to spot things like financial fraud by finding transactions that, conceptually, just don't fit in.
So where is all of this headed? Well, the quest to teach machines true meaning is only speeding up. And the next steps are, frankly, mind-boggling.
To give you a sense of the sheer scale we're talking about, just look at this number, 400 million. That's the number of image and text pairs that one AI model was trained on, just to learn how to connect what we see with the words we use. It's just a colossal effort to build this shared map of meaning.
All right, so let's boil it all down. What are the big ideas to remember? First, embeddings turn abstract meaning into measurable geometry, and that lets computers finally understand relationships. Second, this tech has evolved like crazy, from static words to understanding full context and even pictures. And third, and maybe most importantly, this isn't sci-fi. It's the real tech powering the apps in your pocket right now.
So if AI has learned to map our words and even what we see, what's next? The frontier is already pushing into models that can map sound, that can map physical movement, maybe even emotion, all into that same shared space. And that leaves us with a really fascinating question to think about. What complex human concept will be the next to get translated into the secret language of AI?